Gautam. I work on the Android developer experience team at Uber. My job is basically to keep all the Android developers at Uber productive, and that's why we focus a lot on tools, on CI, things that the developers use day to day, like the IDE, things like that. And today we're going to talk a little bit about the journey of the Android code base at Uber to a monorepo. Basically, we kind of migrated a huge multi-repo setup into monorepo. I wanted to give you guys like a overview of the migration process. It's just not like a should you use monorepo or not, but more that if you had to do this, how would you go about doing it? So with that in mind, I want a quick show of hands from folks. Is that okay? I'm just going to use this. Sorry. It's weird. Okay, there you go. Sorry. All right, quick show of hands. Does anyone work in a monorepo by any chance? Not the Uber folks. Anyone else? All right, we have a few people. Anyone have like maybe a bunch of repos, maybe 10, 15? Okay, that's good. Anyone have 100 repositories? Unlucky folks. Wow, that is someone. All right, so this is probably going to be super useful for you. So quickly going through how the Android code base at Uber was. This is like 3 years ago when I joined. There were very few engineers. We had only one app, which is the Rider app. I'm sure a bunch of you might have used this already. And everything was well and good. We had Android Studio, a simple project, one repository, and everyone was basically productive. And suddenly we wanted to also write a driver app, which meant that we had to use pretty much the same stuff we were using the Rider app, or sometimes we had to like either copy paste code over, or pretty much the same setup. So to kind of make this more seamless, we decided, what if we could share some code? Let's write a shared library. And we kind of made like 3 different repositories now: Rider, driver, and library. And as we had more developers, people started contributing code to these repositories. Things got really interesting, as there would definitely be like things getting too big, or there's just like leakage of like driver concerns into this library, or rider concerns into this library. So we want to kind of separate all that stuff out. So we decided, let's just write some core architectural components like networking, storage, UI. So and we basically put all of these in individual repositories. And we set up an Artifactory instance to kind of upload artifacts from these repositories, so we could consume them in other places. It's very similar to a Maven setup, except it was all internal. So now that we kind of had this set up, and we were encouraging people to be like, hey, like go write your own feature in your own repository, we had like a proliferation of like repositories. So at one point we have, before this monorepo, 100 plus repositories. It's kind of developed organically over 2 years. This is not really a bad thing. In fact, it can be quite good, because if you have a small team working on one repository, you have very clear ownership of your code. You have like a very clear direction, and you don't really need to like coordinate too much with other teams as much when you're day to day. You're not going to step on someone else's toes, and that's really fast. It keeps things moving fast. And at the initial stages of Uber hypergrowth, I think this made a ton of sense. And also like better performance of tools in general, like Android Studio, Git, any other like off-the-shelf tools you have, they perform really well when you have a small code base. So that's another plus. There are also like downsides. One of the biggest being architectural silos. So what does this mean? When you have a lot of different teams working in different repositories, they all tend to have their own rhythm of how they code. So they'll like some design patterns, and they'll say, hey, let's just go use Dagger 2. Someone else will be like, I'm going to use Dagger 1. And now when you try to integrate things, it's not so pretty. Right, so that kind of made it a little harder. So we had to start enforcing some patterns and stuff. And it was not always like easy. Fortunately, one thing we did have that was cross repo was styling. We had some Gradle plugins that would basically ensure everyone used the same code style, and some ID plugins to help out as well. But generally, architecture was a big problem, because there was definitely different components that could not always meld together easily. And there's also a lot of duplication, because if you have 100 repositories, you're not going to go look around and see if someone wrote that utility or like a framework that you wanted to use in your library, in your repository, for example. So especially with a lot of repositories, visibility is really hard, which meant that we would see duplicate code, and the app would just blow it up, because we would just be having like the same thing done twice or thrice. And this is the hardest thing, especially for my team, is keeping things up to date. Like whenever there's a new Gradle update, we would be like, oh, here we go again. So, or Android Gradle plugin for that matter. When they were breaking a lot of stuff initially, it was like really hard to like keep everyone in sync, especially since you wanted to get all the benefits. Another thing that was very hard was like rolling out things like static analysis. So if you wrote like a new lint check, for example, you'd have to go now and say, hey, go update this in like 100 repositories. It's not fun at all. So another thing that is really problematic for people outside like my team is anyone who wants to make a breaking API change. So if you have like these small libraries, and these are all internal libraries, so breaking APIs is not really a big deal. Like if you're not shipping them externally, it makes sense sometimes to like break APIs if you want to like make things better. So if you had to make a breaking API change in say something deep down in the stack, like the core base activity or even like a logging framework, for example, you would have to now go and update every single consumer of this library. And that meant like you had to make multiple commits across different repositories, and you might even miss some. Which means that at runtime, you would basically see like weird errors where this API is not compatible because all of these artifacts were pre-built, which meant that we had not really much checking going on at compile time. And this is really problematic. So a lot of developers had this dependency hell where you would have to go figure out like whenever you do a dependency bump, it had a lot of surprises associated with it. And to kind of aid with that, we had some systems available. We came with the concept of a distributed monorepo. I know it's a weird name, but what it did was anytime someone updated a dependency, we would essentially figure out from the dependency graph if someone else is using your library, we would try to update them to that latest version, go build it, and come back and say, hey, you might be breaking these libraries, so you have to go fix these. It's a little better because at least you knew what you would be breaking, so you could at least go and be like, change these. As an example, I think when we tried to update support library before we had this tool, it took like about 3 months just to like make sure that everything was in sync and everything worked. And when we had this thing around, I think it just took us like 3 days because we at least knew exactly what to fix. We never ended up open sourcing this because we knew we didn't want to keep this for long. But it's not really difficult to do. What you could do is anytime you got an artifact, we would essentially add some metadata to the POMs that says, this is the repo, this is the SHA, and this is the Gradle module path. So whenever we want to like build it against a later version, we would extract that info and just run a Gradle build. All right, so because of all these factors, a bunch of our developers were having like problems like being efficient in their job. And this is not good. As the developer experience team, we felt pretty terrible that people were being slowed down by these problems. So we started looking at like what other companies at scale were doing when faced with the situation. And a lot of companies were using sort of like a monolithic version control. Like Google, Facebook, Twitter, they all kind of have this model where all the sources in one place. And we felt maybe we could give that a shot. It seemed like we had a lot of code out there. And we felt that having it all in one place would make it easy to at least find stuff, edit things quickly in place, and also have like not have to do multiple changes across repositories. So there was definitely like some prior art out there, so we wanted to see if that would make sense for us. And then we set out on figuring out how we would evolve into Monorepo. And usually it's one of the things that I want to point out about this situation is we had some core principles in mind. So one for all for one, from the book Three Musketeers. It's a very favorite book of mine, so it resonated with me a lot. One for all, what does this mean? So one place to find all code and pretty much like all the different things you might need. You don't have to like go look somewhere else to find or to work on something. And all for one, this means that every single person is responsible for keeping it healthy, and everything that we develop in terms of tooling or any sort of updates will go to the mono repository first. So basically fully supported, just one place to like focus your attention on. So after seeing like monorepos being used across the board in different companies, we didn't really figure out like, hey, like no one really talked about how would you do this? Like how would you go about doing this? Especially for Android, I don't think there's many people who do monorepositories. There's usually backend services that do this stuff. So we thought maybe it would be as easy as, wait, this one didn't play correctly. Maybe this will do it again. I had a really funny GIF, promise. Can I like replay this thing? Huh. All right, I'll put the slides up. You can probably look at it later. Sorry about that. But it had this funny gift where we had like the multi-repo just evolves like Pokemon into a monorepo. So that's how it would happen out in the wild, because we didn't really know like how this process works. So as someone might know, you cannot really just simply say, let's just change everything in a monorepo. It's a very huge migration, especially at this scale. So we had to like consider a lot of things. Like first question we ask with any sort of a big migration like this is, if it's a monolith, will it scale? Different aspects have to scale. First thing is, will your version control scale? Like I'm sure many of you use Git. I don't know if people use Mercurial, but first thing we looked at is like, if you had a lot of files and a lot of commits, are we gonna like slow down Git? So we started looking at like some data out there to see like at what point Git might break, and we were nearly not close to that limit yet. So we didn't have that much code compared to like Google, for example. So you're pretty comfortable saying, okay, Git's probably fine, but something that we had to consider. And will the build time scale? So this is another important problem. Back in the day when we were building with Gradle, when you kind of brought all the repositories together into one place, our build times sucked really bad. Maybe like an hour and a half. This is like last year, I think, around August. So we kind of started looking at figuring out the build situation, because it's very important on a day-to-day basis. You want to make sure your developers can build, otherwise you won't be able to like do their jobs. So we developed a plugin for Gradle called OKBuck that translates these Gradle files into Buck files, which is a build system by Facebook. And that scaled really well. So the guys at Facebook have already been using Buck for a while for mobile monorepo, and it felt like a natural fit. We also didn't want to do like a migration inside another migration. So we were like, let's just keep what we have and see if we can like do it live by translating like already the configuration that we had. So that is kind of the motivation for building out this tooling. And we'll develop and scale. So when you have a lot of people, we have about like 200-300 Android devs working on this code base now. We have to make sure that people don't step on each other. So before, when you had multiple repositories, it was very easy because like you wouldn't know what your neighbor is doing. But if you're in the same repository and you feel like, oh, this thing looks like it's broken, let me go refactor, you might be breaking someone else's functionality. So we would always have to be careful about the situation. Merge conflicts are very, very easy to have in a monorepo. So we had to build some tooling to prevent that from happening and to make sure that not just merge conflicts, but also features should not conflict. So if you've added a new API and someone else added another one, and you're not aware of those two things that are happening in parallel, you might start breaking tests once both the things merge. So we had to think of some tooling to prevent that from happening, and we did develop something for it. I'm going to talk about it a bit later. And also we had some examples internally. The iOS folks at Uber already transitioned to monorepo. They wrote a great blog post about it. Of course, their stories are slightly different. They had to go through a lot of these steps completely different from how we did things. So we kind of learned and kind of improved upon those things later on. First thing we did was we had to set up like a mini monorepo. So we wanted to prove out the idea that this would work. So we had an app rewrite last year. The Rider app was rewritten. So we thought, let's try out the new tooling in this new repo. It's fresh. No one's like touching it yet. And people will be generally tolerable because like we're not really breaking existing flows. So we basically started experimenting with like the OKBuck's tool stack, and also like figuring out like what might break in terms of tooling and like CI and all that other stuff in a monorepo. And since it's a new app, a lot of code was being added as well. So it seemed like a lot of people kind of trying to step on each other. So we had to also figure out a solution for that problem. First thing also when considering a rewrite like this is should never rewrite history. I mean, you can rewrite some stuff, but we should keep all the different version control bits as close to how they were before. So basically, the constraint was we could not change the Git history. We had to keep all the SHAs, and every single Git blame should have to work the same way. So there are like tools out there to do this. So we essentially went from this multi-repo structure with like apps and libraries into kind of like one Git folder at the very top. And I did link out to like a script on GitHub. This is not the one that we used, but it's very similar. You would essentially feed it like a text file of repositories, and it would spit out another repo with like everything kind of merged together. It keeps all your Git version history as well. And kind of like, you can also like ask it to update it like on a daily basis if you wanted to. So if you're like doing this at home. So once we kind of had these concerns out of the way, we were like, okay, let's try to like stage this. So we were essentially creating a snapshot of the entire Uber code base every day. We would run the script, have 100 repos being pulled together, and we would create a snapshot. And we would be the unfortunate souls who would go try to build, test, and fix everything. Once we did fix stuff, we would have to go make these commits back into individual repositories. We were trying to make this like as quick as possible, because after a while, like building and fixing other people's code kind of gets old. So fixing breaking API changes was like really, really tough, and we didn't like it. So what we did was we built some tooling again. As we were like kind of getting close to the migration, we did a small Gradle plugin that would essentially check your public API against your previous version. So it would download an artifact from the previous version, and it would essentially run like an API checker. There's like third-party tools out there called Gradle API check, I think, that runs this. So we kind of built a plugin around it, and we said if you break API, it would just CC us and say, please don't break API. You're going to make our lives more miserable than they already were. So, and we would essentially work with the teams to say, hey, let's try to like hold off on this till the migration, or at least try to update it all at once so it doesn't like slow down the migration. So that is very important. I think we didn't have this tooling when we did the iOS migration, and it was very painful for people to find out on the day before the migration that a lot of things are still broken. So this definitely saved us a lot of time. Now let's talk about the rollout. So once we kind of figured out the staging and everything, like the repo worked, we had to do a code freeze, obviously. I know everyone loves a code freeze. So we said, okay, anyone guess how long we froze the code base for? Not you. Any guesses? No. No. We froze the code base for 1 weekend. So that is just like a Saturday and a Sunday. We had to do a lot of prep work to make this happen. So essentially, people don't really commit much on weekends anyway, but we wanted to make sure the window was very small. We could have done it like in a shorter time, but we also wanted to ensure that once we did the full migration, we could account for any edge cases. So we froze the code base for 2 days. Most of the stuff was done live as we were like snapshotting things on a daily basis. So there were not too many surprises, honestly. And then we ran like a big purge across our entire code base. We just went into every single repo and we just deleted every single line of code, because we don't want people coming back on Monday and saying, hey, my repo doesn't work anymore. Like, what did you do? So we basically deleted all the different repositories and put a README there saying, go to the mono repository if you haven't already. It's important because we don't want to like also support this old stack anymore. So just to avoid confusion, it helped a lot. And we added lots of documentation. People who are coming into the new flow, especially they need to know like all the different flows that they had in their previous repos. So documentation is like super critical to have. All right, this GIF works. So support channels, we set up a support channel as well first 2 weeks of the migration to make sure that people who are coming to us for help had some dedicated support. So we'd have people rotating to always like say, hey, like have you tried like hitting the clean and build button or things like that. Because a lot of developers who are not part of the staging repository didn't really know the new stack as much. So along with documentation, we also had to direct them in the right way in many cases. All right, I'm going to go through a few interesting numbers just for fun. After the migration, we had about 75K files in the entire repo. I don't know how that compares out there, but it's definitely not as much. One of the things to like note is Git operations like Git status and like ls. They scale with the number of files. So we also went through some other stuff later on to kind of clean these files up as much as possible. But initially, we didn't want to like disrupt it too much. So we just said, okay, whatever is there is there. We had about 45,000 commits so far, kind of combining all the different repositories. And we did like about 800 my diffs just for migration. So this is the stuff that we were building and fixing on a daily basis and pushing back to repos. So it's still a lot of work. And the size of the repo was about 350 megs because we kind of pruned away all the large binaries that people were checking in. Very important if you do git clone. It's also important if you do CI builds. If you're cloning this repo on like a CI build on Docker or something, you don't want the repo to be too big because you're just spending time cloning instead of building. So we want to keep the footprint minimal. And we had about 680 Gradle modules when we did this migration. That's quite a lot. And the only way we were able to scale was since we've switched the build system. Gradle's gotten a lot better since last year with the Android Gradle plugin 3.x and everything, but it's definitely still was really bad back then. And today we have about 1,000 plus modules. And that's been over the last 6 months. And we're expecting it to grow. So we need to make sure that we also had to take into account the scaling at which we would be like growing. And it's still been holding up pretty well. All right, so we did this great migration, but what did it actually get us? One repository, I can't understate this. This is a huge deal because now people would just be like, hey, I want this function. I'm just going to go to the ID IntelliJ and just search for if someone's written this, or try to just autocomplete and see if something exists. So it is huge. And also, not having to like go find another place where something's there is like really nice to have. One version, so we no longer had semantic versions, no libraries with like version 1, 2, 3, everything is at head, which means that there's no dependency hell. Everything has to be compatible at a particular SHA, and because we build and test everything whenever you make a change, we ensure that nothing's broken at every given point of time. So if you're making breaking API changes, you have to pretty much go fix every consumer of yours. So it had a nice side effect that developers started making like better API decisions. They were pretty much being told that, hey, if you break API, there's this like long tail of things you have to fix. So they would just make better APIs, or they would make a compatibility thing that would just like work. So that kind of helped a lot in terms of like migrations as well, and just made us like better software engineers. One change set, so if you do have to make a breaking API change, you just have to make one diff, not like go to like multiple repositories and kind of struggle with CI and take days on end to like merge your code. So anyone who's gone through this at Uber, you should talk to people here. They will tell you like how useful that is. Just like whenever like updating support libraries, like a really big, interesting use case. Now it would take like maybe half a day instead of 3 days because we would just go fix the places where it's broken. We've actually been able to update a lot of stuff, so because of that. Faster builds. Since everything is in one place, you might think maybe it might slow down because there's just a lot of stuff to build now. But since we kind of switched over to Buck, what we did is we can actually compute what exactly changed when someone makes a code change. Like if you have a change to like a small library, we know what all the different apps that consume it and other libraries that might be using it. And Buck kind of gives us this info, so we would just say, go just build the change stuff and just run their tests. Don't bother like building the entire thing. So we don't do clean builds on CI. Everything's incremental on CI as well as local, so which meant that we could still build fast, even though we have like a large repository, and just like one of the major things to like keep in mind. Always up to date. So if I had to update Gradle, it's just one line change now. It's super awesome for people who work on the tooling side of things because anytime like a new RoboElectric or like Android Gradle plugin comes out, it's super easy to like just go make that one edit. It's not as much as a breaking API change, but it's also easy to like add new linters, for example, to make sure that people are doing the right things. All right, so I kind of touched on this a little bit before about keeping master green. With a lot of people trying to commit code, it's very hard not to conflict with each other. So we had to build some sort of system to like mitigate this. So we built a thing called submit queue, which is essentially think of it like an asynchronous merging Travis of sorts. So what it does is like as people are trying to check in their code, it'll essentially start trying to merge these things one by one, and it'll also run all the tests again against the merge state. So you have like 4 commits coming in. It'll try to first say, okay, let's just try building one, and then for the second commit, what it'll do is it'll try to speculate that what if one fails, are my tests still going to pass? And if one passes, it's going to basically combine both 1 and 2 and try to like run all the tests. So it's kind of like exponential in kind of how it figures out like if it can merge or not. There are algorithms that we develop to kind of mitigate that, but what we guarantee basically is if you see some of the changes, this is like from 2 days ago, I think, they don't take really that much time to build. So we kind of just like push them based on the rebase state, and we only build the stuff that's really changed. So that helped to make sure that master's always green. So we never had a red master ever since we had this. This has definitely been a huge time saver. We are planning to open source this sometime early next year. So definitely be on the lookout for that. Even if you don't have Monorepo, if you have a lot of developers working on one repository, it's super useful still because you can make sure that you don't have to deal with red master and people coming to your desk and like not saying, please fix this right now, I can't work. So don't want a situation at all. Do want to mention a couple of downsides we had because of this, especially in the IDE space. IntelliJ still has like some scaling issues when you have a lot of modules, and we are working on kind of mitigating that by like merging modules together for the IDE to look at. And there are some downsides with tooling. For example, if your repo grows too big over time, like you have to rethink your version control system. I'm sure we'll get there, but we're not there yet. So definitely something like to keep in mind. Definitely the journey is not over yet. We have to still develop a whole bunch of tooling improvements. As I said, the IDE experience is like not super optimal yet. So we are working on that stuff. And also some other things that we're kind of like experimenting with is distributed builds. So people still want to build on MacBook Air for some reason. I don't know why, but they want to get the same performance that someone gets on a MacBook Pro. So what we're doing is we're investing in infrastructure to like build these things on some sort of remote cluster. So all CI and local builds basically get the same experience. We're also doing something interesting in terms of dependencies. So has anyone used AGP 3.x yet at this point? Oh, this one, okay. So there's this new thing in AGP 3 called API versus implementation in terms of dependencies. So you don't really depend on anything for compile. What you say is, I need this as part of my public API, so I'm going to declare it as an API dependency. Otherwise, it's an implementation. This is very useful when you have a lot of modules because it kind of does not leak dependencies to your consumers. So whenever you change something, they're not needlessly rebuilding stuff. So what we want to do essentially is, we haven't migrated yet, but we want to write some tooling to automatically figure out like what's an API and what's an implementation dependency, and kind of keep them in sync. So as people are deleting code or like adding code, we want to like automatically run this tool every day and kind of rewrite the build.gradle file to only have the minimum set of dependencies that you really require. So that way you're not pulling in like all of some other library, even internally or externally, that you don't really need. And we are planning to open source this because it does work with like regular Gradle builds for like Android or non-Android projects. Something that's also coming out early next year, possibly. And the last thing is like duplicate and dead code detection. After the migration, we didn't really like go clean up every single repository that we've kind of pulled in. So we are looking at like static analysis to figure out like, hey, this code is being compiled every time, but it's not being used. So one way we were thinking of doing it was looking at the pro-guarded APKs and basically kind of mapping that back to the code base and saying this code is basically not in the APK. So maybe we don't really need it or keep it around anymore unless you have to. So just kind of a way to like clean up using static code analysis and like dynamic analysis. Definitely try this at home if you have a lot of repositories. Even if you don't have repositories at this point, but you kind of want to have like a lot of modules, there's still some interesting stuff that you're doing with like dependencies that you can kind of like consider in your stack. And if you ever do try like a migration like this, make sure your tooling scales, because this is really important because you don't want to have to do the migration and later find out that it's actually slower than it was before. So try doing like a staging thing, set up like something small. And there are like scripts that I linked to that you can like try this out really quickly and like just do like a build, see if it works out or not. And yeah, just like experiment with it if you really wanted to. And that's it. I hope you got some good overview of this thing. Questions?